Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim Hisham, and today I will present to you my final year project, Centralized Geospatial and Cable Mapping Information System. In introduction, I will explain briefly about my final year project. My project is about study how to interpret data of underground cables into 2D and 3D perspective view. The data are being collected by mapping its coordinate and depth. This data are acquired with the help of Tenaga Nasional Berhad, TNB, Zone JBRU. This project took place at Tanjung Lansat Industrial Area. For further detail, I will explain it in poster presentation. This is my poster, so I will explain each section detail one by one. Projection description. So in this research is about to display the coordinate and depth of the underground cables in 2D and 3D perspective view. The software that being used in the research is AutoCAD because it can draw and display either in 2D or 3D perspective view. AutoCAD can draw the underground cable accurately, and it is easy to handle it, especially for the beginner. Introduction. In introduction, I will explain to you what is underground cables. An underground cables is a wire hidden under the ground for the delivery of electric power or telecommunication. Underground cables are an alternative to multimeter above ground overhead cables. So they are typically little to no overhead cables in urban areas, especially in industrial area. Since the underground cables are not visible, it is less dangerous to people because they are out of the way. While underground cables are more costly to install, they last longer. A standard underground cable consists of conductors that are shielded by a number of isolating and protective layers necessary for their satisfactory operation. There are three types of high voltage underground cable, which are directly buried, through, and tunnel. TNB usually use directly buried process to install their underground cables. The objective of this research is to collect data on underground mapping, identify coordinates of the underground cables, and to interpret the data in 2D and 3D view. Problem statement. In problem statement, I will explain to you what is HDD or horizontal directional drilling. HDD is a trenchless boring process for installing underground wires, valves, and conduit along a specific bore in a shallow curved track using a conditioned surface launch rig or machines. Surface launch rig or machines minimize the interruption of the surrounding area, which are roads and driveways. If we compare to exposed pits, health hazards of HDD are often reduced and are well tailored to high volume traffic conditions. As we know, trenching and excavation work is often much more expensive and inconvenient. So, when HDD comes in, it reduces the cost of reinstatement for roads, border, and driveways. The problem comes in when the site has many underground cables. When a new cable needs to be installed for a new contractor request, a new depth of the installation needs to be determined precisely. If the surface launch machine touches other cables during the process, the cable might be cut and damaged. This damage will cause a problem to replace the damaged cable. The process to replace the cable also takes a lot of time and cost. Methodology. In methodology, there are three steps have been take place in this project. The first step is site survey. Before we gather the data, the site needs to be surveyed to indicate how the environment. This site located on Tanjung Lansat. Tanjung Lansat Industrial Complex is located in the southeastern portion of Johor, which is about 8 km from the industrial city of Pasir Gudang. The industrial complex of 5,000 acres was built to cater for the small, medium and heavy industries. The second step is mapping coordinate of the underground cables. In order to gather the data, several equipment is used to locate the data coordination of the cable. The equipment were cable avoidance tools, or we can call it CAT, and ground penetrating radar, GPR. To avoid the cables, CAT is used on the foundation, mining, and building sites to find cables. Naturally, the CAT can sense the signals radiating from metallic surfaces. GPR is the utility mapping method of choice. It emits electromagnetic directional waves in the frequency range of MHz and GHz, and use the return signal to identify the location of the subsurface utility infrastructure. GPR technology is extremely reliable and can be used to identify metal and non-metal services. Surveyors tend to prefer using GPR to carry out utility mapping survey because it provides fast data acquisition, low operating costs, and high resolution imagery. The third step in this methodology is interpret data into two-dimensional and three-dimensional view. The data are interpreted into a better view in order to locate the underground cables. AutoCAD has been used for modeling and drafting. It allows a user to conceptualize ideas, product designs, and drawing to the required level of technical accuracy, perform quick design, calculation, and manufacturing industry simulations. To determine the most desirable method to be employed for each portion of mapping project, the alternative of scanning, board digitization, and coordinate geometry must be evaluated. Result and analysis. In this section, I will explain to you my result of my project. On the left side is the data obtained from viewpoint apps that have been scanned by using GPR. Viewpoint apps is an application for Android data acquisition that controls the crossover and pinpoint arc antennas of impulse radar. Viewpoint allows wireless communication between the user and the GPR antenna when mounted on a suitable Android device such as smartphone or tablet. As you can see in the table and figure, it shows the depth and location of the underground cable. And for the right side is the data that obtained from TNB. As you can see on the right side is the figure of map that have been drawn by the TNB. The marking point of A represents the starting point, the underground cable crossing the road, and to the point D, which is the end point of the end line crossing point. The marking point R is indicate for the index 1 on the left side. As for the B point, it indicates for the index 2 on the left side, and the Y marking point is for the index number 3. After all the data have been acquired, the data have been interpreted into 2D view and 3D perspective view. This is the image of the top view of after the data have been acquired and be interpreted into 2D top view. This figure shows the front view of the line crossing point from point A to point D, and also the data have been labeled in the figure. Other than 2D perspective view, we interpret the data into 3D perspective view to give a better view of the underground cables. Conclusion. The conclusion that can be made from the research is the objective of the research are reached where to display the data in 2D and 3D perspective view. This research will help companies such as TNB to view and enable them to install a new cable without damaging the other cables. Nowadays, there are many underground cables have been installed. In order to apply more of this method, this research are helping Negara Nasional Berhad to implement this method in the future. Damaged underground cables can be a big problem and will take a high cost to replace a new cable. HDD is the most common method to install underground cables. This research is being carried out to minimize the probability underground cable being damaged during installation. This is the data that has been obtained from TNB. This color line indicates for the TNB line, and for the blue is the drain, and this cyan color is for water pipe, and the yellow is for gas pipe. As we can see, this is the point where the starting point for the line crossing point to the D point, which is the ending point. This line is indicate for 132 kilovolt. As for this is the field report, which is the data acquired from Viewpoint apps. Viewpoint apps shows the depth and the index number for each depth. As we can see here, each index shows the different depth. For example, for this is 1.3 meter, number 2 is 1.3 meter, and number 3 is 0.93 meters. From this data, we will interpret it into 2D and 3D perspective view. After all the data have been acquired, the data are interpreted into this drawing. This is the 3D modeling drawing. At this point is the A point. A point indicates the starting point for the line crossing point for the underground cable to cross the road to the D point. D point is the end point for the line crossing point. In between A and D, there are point R, B, and Y, which is R for the red line cable, B for blue line cable, and Y for yellow line cable. In this area is where the R point located, which it means the point indicates that the underground cable start to curve to the new depth to the point D. Same goes for point B and Y. This area is located the point B, which indicate that from this point the underground cable starts to curve to the new depth to the point D, and for the Y point is in this area. As we can see, these three cables are connected to the link box, which the three link box supply 132 kilovolt to the factories. So this is the result after interpret the data into 3D modeling. As we can see now, this is the top view for the 2D view from the data that we acquired. So you can see, this is the point, located the A point, and in the end of the line crossing is the D point. This is the view for the front view in 2D. As we can see, this is the A point, which is the starting point for the line crossing point, and this is where the D point indicates for end point for line crossing point. As we can see here, there is a curve for the underground cable to change to curve to the new depth. Same goes for the red and blue cables. This all have been interpreted from the data that we acquired earlier. This is the view when we see it in 3D modeling. As we can see, the cable are curved in different depth, just like in the data. We change it into X-ray, we can see clearly how the cable cross the road.